Hello, good afternoon once again. This is the fourth part of our tutorial video series for this ESP32 LoRa boards. I'm going to show you how we can program this thing as our LoRa node. It's quite simple. Again, I've connected the DHT11 here to pin 17 as to provide temperature and humidity readings of our sensor node and connect it to our LoRa gateway. Okay, I've loaded up the code for our sensor node here. By the way, before all this, let me just try to show you where you can get the source code for this one. I've uploaded all the code for my gateway and the LoRa sensor node into my GitHub. You can probably just clone it or download it and modify it if you want to. It's under this particular link right here. github.com ppcola. I'm not sure if you can see that one correctly, but you should be able to see it. That's the link. And first thing you need to do is to install the libraries in your Arduino folder. That's usually under documents/Arduino/libraries. So after you've downloaded, just copy all the files there. I've already modified some of the libraries, for example, like the LMSE library that you see here. I've modified that one to work with 915 megahertz. If you're on the different parts of the world, for example, you can go into IBM LMIC, go to SRC. There's a config.h here that you'll see in LMIC. Modify that one. Right now I'm using US 915, but you can probably make use of other frequencies as well. Okay, so yeah, so let's head over to Arduino and examine our code. First things first, you need to change the device address, the network session key, and the application session key. So they're at the very top of the file. So you need to modify that one in order to adapt to your settings. That should be equivalent to the, if you go over to Things Network, go over to Settings, and the EUIs here, access keys, sorry, let's go to Overview. So you have the access keys. I have two registered device nodes here, so let me check the correct one. Okay, so your network session key and the application session key are listed here. So you just need to copy this thing into your code, to your Arduino code. Don't forget the device address as well. It must match. Other than that, you go down, look at the settings of your pin mapping. Now this one, the pin mappings that I've set here is actually for this particular board. It also applies to the Heltec Lora32 boards because they are basically identical in terms of pin mappings. The DHT11 is connected to pin 17 as I mentioned earlier. I'm not using this. I'm actually supposed to connect the GPS receiver to provide some location information, but I'm not using this. I'm using Cayenne LPP and the DHT11 sensor library as well as the SSD1306 for the OLED library. Make sure those libraries are installed, or if you copied all the libraries that I had in my GitHub, then you should be good to go. Okay, so let me try to explain a little bit about the code. We'll go first to the setup where we set up our peripherals. We're communicating with 115200 baud rate on our serial port. Since I'm not using GPS serial, let's just leave it at that. And then we initialize the OLED library. There's actually pin 16 here that's connected to the reset pin of the OLED library. So make sure you turn that one on and then off and then high again. So this is the part that does that. Reset it to output, send it to low to reset the OLED, and set it back to high. and then we initialize the display, assign some points into it, and then we also initialize our DHT11 with the same with pin 17. And this is the most important part. We are setting up our LMIC to connect to LoraWan. This is where we set up our application session key and network session key, as well as our device address. For the 915 megahertz range, you need to call this LMIC select subband 0, which is basically the function to select at which particular frequency bands. There are actually multiple frequencies for 915. You need to select at which particular band you're going to be transmitting data from. SF9 is needed for the RX2 window of TTN, and this is the spreading factor that we're setting in is actually SF7. As I mentioned earlier in the Lora Gateway setup code, we are actually using spreading factor 7, so it needs to match. So in my Lora node, I set DR SF7, and then after all has been set up and done, we do a send job. Okay, now the LMIC has its own internal state machine, so whenever there's an event or anything that changes, it actually calls this callback function on event. And what we do here is we basically just check whether the event is referring to a transaction complete or transmit complete. And if ever that happens, we just simply call a set time callback to call a certain function sometime later on. So if you notice this one here, send job, always get time, some session for some transmission interval. Our fixed interval is actually set now at around 10. And right after that interval has passed, you call the do send function. So what is in the do send function? Well, quite simple. First, need to check whether we are transmitting or has finished transmitting. If we have finished transmitting, then we are going to fill up our payload, the data that we're going to send to TTN, with some temperature and humidity values, and that involves reading the DHT11 for the current temperature and humidity. We reset the payload. As you can see here, I called LPP reset. Oh. Okay, that's better. So notice I called LPP reset. Then I add the temperature. Wait a minute, I forgot to set my camera. So I added the temperature and humidity settings here. Cayenne LPP automatically translates that, encodes that into a format which is quite small, suitable for very small devices like a microcontroller that we have. And right after we encoded the payload, we then call the LMIC TX data 2, which basically transmits our data to our gateway and eventually into the Things network. And passed into that function is actually the buffer from the payload and the size of that buffer. So going back into this function here, add temperature, you notice that I added the first parameter as 1, 2. This actually refers to the channel that you are sending it to. If you have a GPS, for example, then that would be channel 3. As you can see here in the commented out code, GPS, add GPS, it's going into channel 3. So why do we have this LPP packet format? Well, if you go back to the Things network, and let's go back into our data settings here, you notice that automatically the Things network recognizes the data that is in our payload. So it automatically recognizes that we have a humidity data as well as a temperature data. Okay, so if I expand that out, you see it's automatically recognizing the temperature and humidity values that we're putting into. So how do we set up TTN to recognize this particular type of data format? Okay, so first things first, you go to Citron Shield. This is my application, Citron Shield. and you go into payload formats here,